Hello, everyone. Welcome to today's talk. So today we'll talk about Web3, and the title is named Web3 Wonders, but it's a talk about blockchain and generally Web3. We decided on this topic because we think it's interesting, and I think we're next year is going to be an interesting time for blockchain again, because now it's a little bit wind down, but this will be an intro into blockchain development. So little about me. My name is Nikola. I'm from IPAM, Serbia, here in Novi Sad. I'm a senior software engineer, and I recommend that if you can come to the Novi Sad office, because we have a big, nice office for you to work in. And yeah, so that's me. I'll be your host today, and this will be more of a hands-on talk, meaning that we'll have a coding demo, and we'll have a few slides first to explain the topic, and then we'll have the demo, which will be I'll do the live coding. So demos don't usually go well live, but we'll see. We'll hopefully it all works. Okay, so today's topic is it's called Web3 Wonders. It's an easy intro into Solidity and React, and it's a part of JS community Balkans. We're a community that for the Balkans, and we hold talks, and we'll probably next year create some hangouts and meetings. But we usually what we do is give people some topics that we think are interesting, and we have talks about them, and also workshops and other stuff. So if you want, you can check us out. We have an Instagram page. So yeah, and okay, so let's start with first with what is Web2, because when we talk about blockchain, you usually heard Web3 and so on, and I think most people are already familiar with this, but I'm just going to repeat it in case someone doesn't know. And so what was Web 2? So Web 2 was everything up until now that we had, like all the apps, for example, Facebook, YouTube, Twitter. Is these big tech companies that created applications that we users use each day. And the thing about them was that they were usually centralized, and they were usually controlled by one big company. Like, for example, Facebook now Meta, YouTube, which is Google, and Twitter, or now X. It was Twitter before, now X. And so the main thing is that all of these companies were controlled in one centralized place, and they had their own databases, and they had pretty much control over everything that goes in. Like one of the things like we had with Twitter, when let's say Elon Musk bought Twitter, he said that they controlled much of the output there on Twitter, like tweets and everything. So it was pretty much a controlled entity, and so that was Web 2. And now we have in the last few years we heard about Web 3, which is an attempt to make everything decentralized, and to have a secure way of doing transactions and creating applications in a way that there's no middleman, there's no central point where everything, all the data goes. So what is Web3? Well, you probably heard about it, and there are some words that describe it, like decentralized and secure. There's no middleman, it's peer-to-peer. So for example, the example of no middleman would be when you're doing transactions on the blockchain, there's no bank in between that will do the transaction for you. It's all happening there on the blockchain. So in that way, there's no one in the middle. And so we have the decentralized and secure because we want to have we don't want to put everything in one place, like on one server or in one database. And you'll see how that is done in blockchain, and it's peer-to-peer. You'll also see, I'll talk about how this concept works. So you probably heard all these words, so I'm just going to go to the next slide. So usually with a Web2 application, you would have like your code, your backend code, let's say, and you would choose some of these languages, Python, Node, and so on. And what would you do is when you finish that, when you write that code, you will deploy your application to some server on let's say AWS or any other cloud provider, and it will all be stored there. And your users will basically communicate with that server in order to get the data from your application. So how is it different now? Well, it is a lot similar in concepts of writing code and deploying. We have a code which on the left is Solidity language, and though all the things that we're talking about today is related to Ethereum blockchain. So there are other blockchains that might not use Solidity, it might use something else, and might not have smart contracts like Bitcoin, for example. They only have just normal transactions, no logic or no way of creating code in smart contracts. But today we're talking most about Ethereum because it's the most popular one, and Ethereum introduced this concept of smart contracts and a way to write them in Solidity. So what we will do with Web3, for example, you have a decentralized app on Ethereum blockchain, and you would write some code in Solidity, and then you would deploy that contract, that smart contract, to the blockchain, and that will be basically your backend and your database. We'll see how that works. Okay, so what about authentication? So if we don't have a server, a centralized server, and we don't have a database, like centralized database, then how do we handle, for example, user authentication? Well, it's done with two set of keys. We have a private key and a public key. You get these when you create your wallet online. And private key is basically a way to send transactions, and you sign them with private key. And then you have a public key where you receive your transaction, your Ethereum, for example, and that's signed with your public key. And so you can send, if you know someone's public key, you can send transfers of funds to that wallet, and so on. And so how do you, when you create these keys, how do you actually use them in your application? Well, for example, you have something like React, which can communicate with a wallet. And in this case, the most popular wallet right now is called MetaMask, and that's what you see on the right. And so you can see that you have some Ethereum here, and you have your, so this is your public address, or your public key, sorry. So that's from the last slide. So this is your public key. And if you know someone's public key, you can send funds to them, and you can also, that's your user authentication, basically. That's your way of identifying on the blockchain. And so what the demo will be about is creating the smart contract on the blockchain, and then using a React app or Next.js app to communicate with this MetaMask wallet, and basically send funds to the contract and so on, buy stuff, and you'll see, we'll go through it. So just a quick overview of the blockchain. So it's some kind of definition would be, it's a decentralized distributed ledger technology that enables secure and transparent record keeping. What this means is that basically each block in the blockchain, each node has the entire blockchain transactions, the version that they have, and then all the other nodes have the same version, or they try to have the same version. And so it operates on a peer-to-peer network, and we have something called, so all the information is stored in blocks, and therefore blockchain, and each block contains a list of transactions that happened. And then these blocks are linked together chronologically, and they form a chain, like a chain of blocks. And each block represents a transaction or a list of transactions. And so what we also have here is we need to have some kind of a consensus mechanism to validate these blocks. And so there's a lot of talk about that in the Ethereum about proof of stake and proof of work consensus mechanisms. Currently, Ethereum was on proof of work, and now it's on proof of stake. And we can get a lot deeper in that, but that's not the topic for today. Okay, so common use cases: cryptocurrency, DeFi, finance, blockchain, so on. Healthcare, voting systems, for example, is an interesting one. And we have like cross-border transactions, fraud prevention, and so on. So these are also common cases. Now, of course, there's also a lot of scams used for this, which was not the intention of the technology, but that's how it ended up. So yeah. So today, these are the stack overview that we'll be using. On the first thing, we have Truffle, which is contract compilation, contract deployment. Now you can use a lot of different here. So for example, Hardhat or their Third Web, and there are a lot of other tools to compile your contract. But we'll use Truffle because I think it's the easiest one, and it works well with Ganache. So Ganache is a blockchain development environment, and it's like your node server, for example. We'll go through it now, and then it gives you accounts in Ether that you can use. And then we have the MetaMask wallet, which we talked about, and we have our Next.js frontend framework, which will be a dApp, and we have the Solidity smart contract language that we'll use. So this is like a tech stack overview and we'll go through each of these tools now. So it's demo time. Now, bear in mind that not all demos end well, so we'll try to do our best. So we'll just switch over to VS Code, and then we can start. So first thing is I have created a project here in VS Code, and we'll go through the files. But first thing, I'll just check if we have the correct version of Node. No, we have to use 18. Okay. So the first thing I want to show is actually Ganache, and this will be like our blockchain simulator or our server. And so what we'll do is create a quick start, which will spin up the server. And you can see here that we have it gave us some accounts. So this is the public key of each account, and it has 100 Ethereum balance that we can use to test this. You can see like it's network 5777 network ID, and it's running on HTTP localhost, and this is the port. So currently we don't have any transactions here or any blocks. We have only one block here that's automatically created when you start the server. Okay, so that's Ganache. So I'll show you how it's used. That will be our server, and then the first thing we need to do is to install Truffle, which I think it's already installed, but let's just run it anyway. Now, while that's installing, I'll just go through the files quickly. So it's just the next project. We have our app directory, which we have our main page. We have some components for the marketplace. So what we'll be creating is a marketplace of products that you can put on the blockchain, and you can basically post and buy these products using Ethereum. So we have some components here. We'll go through them when we start implementing, and then we have some hooks that will be primarily used to communicate with the contract itself. And we have some utils, and then what we'll do first, while this is installing, because it's taking its time, what we'll do first is we'll create a contracts folder, and we'll create a Solidity file called marketplace, and this will be our smart contract. So this is the way where you write. This is where you will be writing your backend code. So the first thing, before we start writing our contract, we need to set up Truffle, and that is the first tool that I showed on the slide. And this is used primarily to compile your contract. So before you deploy them to the blockchain, you need to compile them first. So we'll do networks development. Okay, so Copilot is giving us some host. Okay, I think this is good. We just need to change the port to this 7545. Okay, and we'll also do so the contracts directory will be source contracts. That's this folder, and then we need the ABI directory, which is basically where we build where there's the output of the compilation itself for the contract, and that is something called ABI. So compilers, okay, we'll use that. We'll use version 3 or 8.3, and that is our configuration. So what we'll do next is go into our contract and we'll start going to writing our contract. So the first thing that we need to say is what version of Solidity do we use. So we'll say Pragma Solidity, and in this case it will be 08. Solidity. Okay. So we'll just generate this identifier. Okay, so we can start writing our contract. So the keyword is contract, and here we'll call it marketplace. And so you can see this reminds a lot of like the way classes work, for example, in Java or JavaScript or whatever language. So the first thing we want to have is our, okay, so we have our name, and it's written like this. And this will be the name of our contract. And now in the constructor, we can say that this name is equal Web3, let's say Web3 Wonders. And so what will this do? It will, once we deploy our contract, it will initialize the name to this variable. So what we can do now that we have the truffle config and we have the marketplace Solidity file, we can write truffle compile, which will compile our contract to this ABI's JSON file. So this is your output of the compiled contract. So you can see it's a really long JSON file. So what we'll do now is, so every marketplace has a list of products that you can sell, right? And so what we can do is we can add a, okay, that's good. We have a product count, and this will be an inside integer, and then we want to have some kind of storage where we can save the products of our marketplace. So we'll say, let's first create a struct which will represent a product. Copilot is giving me, I think this is fine. Okay, so we'll have ID name. We might want to have a description here. And so we'll create a mapping of, okay, it's giving me, okay, nice. So this is a mapping of integers to products. It's basically like similar the way the JavaScript objects work. It's a hash table, and this will be basically where we save our products. It will be a list of all the products on the blockchain. Okay, so now that we have the name, we have the product count, like how many products there are, and we have the mapping for each product, we can now create our first function, which will be create product, let's say. Okay, it's giving me something. I think so. It's giving us. So we have few. Let's just see what it does to speed up. So we have string, memory name, and description and price. So these are basically your inputs to this function or your parameters. And the word memory here just represents that this is stored in the memory and not on the stack. And we have basically all strings are usually saved as a memory, and uint is just a storage saved in storage. And this is important because when you're writing your contracts, it's really important to make them fast and efficient. And you'll see why, because we have the transactions fees, and the more complex your functions are, the more gas fee it will take to run your transaction. So the first 3 lines here are just checking if this name and description and price are greater than 0. So they're just our validators before we run the transaction. And then we have product count. We increase the product count by 1, and then we create a new product with these values with the product count. So our product count will actually be used to index our products like an ID. And I think we won't need this event right now, so we'll delete that. And one important thing to see here is this message.sender. So each function in Solidity will have the message object on it, which will have data like sender, value, gas, and so on. So this message will actually be your context of your function. So for example, when a user calls this create product from the front end, they'll actually say who is sending, like what is the wallet address of who is calling this function, and that will be this message.sender variable. and so it will be called payable. We'll just cast it to be a payable. You'll see why, because this is something that we need to do to transfer the funds later. We need to mark it as payable. Okay, so we create the product here, and then that's create product, and then we can create another function called purchase product. And so it will accept an ID of the product. It will be public, and it will be also payable. It will be able to send funds to some other contract. Okay, so the first thing, okay, this is giving me something. Let's just see if this is good. So product, fetch the product ID. Okay, mark it as, we don't need this. So I think this is actually fine. So what we do is we actually first fetch the product using that ID that we get, and then we take the seller. So who is the current owner of this product? We put it into this variable. We save his address. Then we do some validation that all of these values, like that the method, like the amount of Ethereum that we sent is bigger than the product price, and we check if it's purchased or not, and so on. And so here, the important thing is that we transfer ownership of this product. So we say product owner is actually a message sender. So the one who initiated this purchase product function will actually be the new owner. So he's purchasing this product, and this will be saved on the blockchain. And so then we update the product, and we basically transfer. We first say that this is a payable variable, and then we call the transfer on it. And here is where we transfer the value from the contract, from the amount that the user sent into this contract. So that's our purchase product, and I think this looks good now. So I'll just be able to, I should be able to compile it now. Okay, and then we can create a migration. Let's create a folder for migrations. So this is similar like running a migration for your database. So what we'll do here is say contract name, artifacts require, and this will be called. So here what you need to put is actually your marketplace contract name. So this, and so we'll do that, and then we'll do model exports. Okay, it will finish everything for me. Nice. So what we need here, we need this to just say what contract are we deploying to the, what in our migration, what contract are we deploying to the blockchain. So we can do now truffle, I think it's truffle migrate. And so, okay, so it says connect 7545. Just a second. So in our truffle config, we said that the local host 7545. So let's just try and have it like this instead of localhost. Let's see if that works. No. Okay, let's return back to localhost. I think this should be, yeah, this is good. So compile. Everything's up to date. Okay, let's try again. So something went wrong. Check your network configuration. I think network is fine. That's all fine. So yeah, we usually get these kind of errors when doing a demo, so it's interesting. Localhost. Okay. Marketplace JSON. Okay, we'll just switch to our working version because we're running out of time and we need to have this. So let's just do this and change to our working version, which should have everything. So let's just run, oh, not that. So I just have compile again. So you can see that this version is, we have the marketplace, which is the same contract that we wrote, and we'll just say now truffle migrate. Okay, so now it works for some reason. Cool. So what we did is we now deployed our contract. So if you go to transactions, you can see the contract creation here, this value, and you can see the contract address. So this public key is actually the contract address that we'll be using to connect with this contract and call the functions that we created. So if I run the application now, so this is our application, and now you can see it says please connect your MetaMask wallet. So we will do that. You can install the MetaMask extension. So we have some accounts here. Okay, and then okay, so it connected our account, but we have zero Ethereum. So what we'll do is actually take one of these addresses. So it gives you all the accounts that you can use for development. So we'll just copy the private key here, and we'll import it in our MetaMask. So we can go here and we can say add account and import account, and here it asks you for the private key of your account, and this is you know the private key here, so no one else can import your wallet. And so you can see now that we have 99 Ethereum, which is great. And now we can create a product here, for example, product 1. And then we have the price. So if you remember from our contract, we have, when creating a product, we give it a price, and this price is not in Ethereum, but it's in Way. And Way is basically it's like you can convert Way to Ethereum just by there's a formula to do that, but it's just like a different currency that smart contracts use instead of Ethereum. But this will be shown as Ethereum, so I'll give it just a big value because 1 Ethereum is a lot of Way, so at least something like this. And let's say post, and now you can see that it opened this. Okay, we'll reject this. Just see if we're connected. Yeah, we're not connected, so let's just connect to the account 6. That's the one that we imported, and we'll just let's import it again. And so we'll put post, and you can see, okay, it says that you don't have enough Ethereum. Did it connect? Let me just reload maybe. Okay, it's now it's connected. Yeah, so we'll just reject this now, and so you can see that account is this one. So we'll do now and put some type of way. And what we'll do is post this, and so you can now see that we have an estimated gas, and this is the transaction fee that I was talking about when creating your contract. Depending on how complex it is, it will take some gas or some transaction or to run on the actual network. And this will, in case this will be this amount of Ethereum. So let's just say confirm, and we have here created the product. And so now when let's import another account. So let's import the second account here. And we'll go to MetaMask. We'll import that one. Here it is. Okay, let's just reload. It didn't change, so let's just connect it. Reload again. And now you can see that we're on a different address, and now we actually see this button to buy this product. So we can click on that, and you can see that that amount of Way is actually this amount of Ethereum. And so here on the MetaMask, we see that the transaction is this amount of Ethereum, and we have some estimated time of gas, and then we confirm, and now we own this item. So that's how we use our contract to actually create some kind of logic, like backend logic, to holding basically have a working marketplace on the blockchain. So all of these, if you open Ganache again, when you go to the transaction, you can see all of these. So this is the contract creation, and then we have the actual contract call for creating a product, and we have actual contract call for purchasing that product. So these are basically your blocks in the blockchain. So each of these is one block, and you can see that we have 4 blocks in total. So I think we run out of time, but that was basically in a small demo of how you can create a smart contract, and you can do anything with it. Like you can save, you can do different kind of dApps, in this case marketplace, and you can basically use the Solidity to put your custom logic in the Ethereum transactions. So yeah, that's basically the demo. So let's just go back to the presentation. Are there any questions, or maybe questions that I can answer to you? This was kind of rushed because we didn't have much time, but I hopefully explained enough about creating a Solidity contract and actually deploying it to the blockchain. I think it's pretty straightforward. If not, then I guess that'll be it. Thank you.
So I see there are no questions, no comments. Maybe we can end this translation. Yeah. Thank you very much.
Did we end the stream?
1 second. No, we're waiting for comments.
Okay.
Don't hesitate. Maybe show 1 minute and then we end the stream.
Cool. And so yeah, I think that all of these, like you have a lot of examples online and that you can learn from, but the main thing is learning Solidity first, and then like if you already know React, it should be pretty easy to implement your own dApp, at least some starter version of it.
Okay, thank you. Please write comments down below for this video if you have questions. See you on the next Text Next or next our meetups. Thank you very much. Bye-bye.
Bye.